Okay, I want to look at section 7.2, where now we are estimating a population mean with a confidence interval. So it's a lot like finding a confidence interval for a proportion. So we're going to use X bar to target mu the mean. It's going to look just like this. We're going to find a margin of error subtracted from our sample mean. That's going to be less than mu, which is going to be less than X bar plus the margin of error. So the big thing now is the analysis on finding the margin of error. It's going to be a little bit different because we're not going to use Z. We're going to use something called a t-score, as in Tom. So I guess since we're going to do a 95% confidence interval in the example, I want to look at the analysis where I always draw the diagram. I know that in between here is going to be 0.95. So I know that my alpha is 0.05. So we always get our alpha over 2. So I want the area in this tail, which is 0.025, gives me the same area in this tail. So the reason I do that is it's going to help me find this t-score. Can't do an alpha over 2 very well. Before we use the z-score, we're going to learn to use a new table, find this t, and then it's this t that's going to help us calculate the margin of error. So we do have requirements. Remember with the proportion, we were looking at the binomial probability distribution. Here, we want an SRS, and we look at either one. Either our sample size is 30, or a lot of times you'll see in a problem, it'll say the population is normally distributed. When I do the example that I'm going to do for this section, I will show you another way to test this for us. We can quickly look at a dot plot. Okay, here's the margin of error. Notice what's in this. It's that t-score that we got to learn to find yet. We got our sample standard deviation, and we have the square root of the sample size. Now, this n-1 degrees of freedom, that's going to help us find the t when we get to that. So just a little bit of theory on the t distribution, not much. Notice it looks a lot like a normal curve, but it changes depending on the sample size. As n gets really big, so for really big sample sizes, t basically becomes a z-score, but that'd be really big sample sizes. Okay, that's that. So this goes back to my picture, my analysis. I've got the t that I want. I've got 0.025 here. I have 0.025 here, 0.95 in the middle. Now, n is 15. So degrees of freedom is 1 less than that, is 14. So I'm going to jump down. Don't get car sick. We're going to go find the t-chart in our Triola formulas. And I believe it's on 19 of this notes. There it is, t distribution. I'll show you the big things. So there's 2 things we need. We need column and we need row. I'm going to do the row first because that's my degrees of freedom. So there's my row because our degrees of freedom was 14. Now, in my analysis, area in one of the tails was this, 0.025, or the area in two tails is that. When I'm doing confidence intervals, I tend to do the area in two tails because that's my alpha, or 1 minus my confidence interval. So that's my column. I go down here. There's my T. That takes me back to my margin of error. So I just found this T value was 2.145. We're going to use that in the problem we're going to do because we're going to have a sample of size 15. So did that. There's our problem. We got sample of 15, so N is 15. The mean is 30 hectograms, or I guess that's 3,000 grams. Standard deviation 2.9 hectograms. We want a 95% confidence interval. So if I do the analysis, we've already got it. We did it basically. We know the margin of error is T alpha over 2 times S over the square root of N. That's 2.145. S is 2.9. That's not what I want. Times S is 2.9. And now make sure you put the original N in there, which is 15. So I'm going to calculate that margin of error. I got 1.61. And it would be these HG things, but I won't worry too much about that. Okay. So before I construct the confidence interval, I do want to just check for normality. N is less than 15. So it's not greater than 30, so I can't use that. It didn't say that the population was normally distributed. Usually it is. If we're given something like this, some sample data, and this will come up when we're working with standard deviation. Just do a quick dot plot. So let's see, what are we going from? Smallest things like 26. And I'm going to go by twos. And how far do I have to go? What's my biggest one? 37, so I need a 38. Okay, so I have a 33. I have a 28, another 33, 37, 31, 32, 31, another 28, 34, 28, 33, this is fun, 26, a 30, 31, and 28. Okay, so if I look at this, if I kind of just look at the shape, we're a little skewed to the right. So it's not perfectly normal, but it's not really, really bad. But I would say this, because we're not really normal, I don't know how valid our results will be, but this isn't bad. So I'm going to give it a check. Looks like we're normal. We can proceed. So, forgot what my margin of error was. That was smart of me. 1.61. So I'm going to construct it. So now we're doing the mechanics. We're right where we were. So I've got 30 subtract 1.61. I went around the 28.4. It's less than mu. It's less than 31.6. And that's hectograms or hundreds of grams. So what we can say now, given our sample, we could say that we are 95% confident the true weight of girls, notice we're talking about the population now, lies in our interval. So we just built a confidence interval for the mean weight of newly born girls. So I guess to finish, I'm just going to erase some stuff here, because we've got this. I want to just say a lot of times we will start a problem with a claim. Suppose the claim is the mean weight of girls is 32.0 hectograms. Well, 32.0 lies outside of our interval. So what we could do, we can now reject this claim because evidence suggests and now you finish with 95% confident that the true weight of girls lies in this interval. So when the claim is outside of our confidence interval, we can reject it. If it lies within, say, the claim was, I don't know, 30, well, we would fail to reject because we have no evidence suggesting that it is not 30. So this would be fail to reject. That's like the worst handwriting ever. And that's this section in a nutshell.